Hi everyone and welcome to our hyperbola lessons. Now today we're going to look at the same two examples as in our previous lesson. But I really want to show you in this lesson the effects of left or right movements and up and down movements on the entire system. So here we go. We are given this following hyperbola, and as you can see we have fx equals to 3 over x, and there is no left or right movement because there's no p and there is no q. In fact, both of them are 0. Now here is our y-axis and our x-axis, so we always start with our hyperbolas by drawing in our asymptotes. Now just because we don't see them doesn't mean they don't exist, because p is a 0, so that means our vertical asymptote must go through the x-axis at 0. So I'm going to draw it in. There we go. So it's going to be on the y-axis, going to go through our x-axis at 0, and there is our vertical asymptote. The equation for this vertical asymptote is x equal to 0. Okay, you remember that, right? Now, how about our horizontal asymptote? Just because we don't see the q doesn't mean it's not there. It's also a 0. So that means our horizontal asymptote goes through the y-axis at 0. So it's going to be drawn on the x-axis, and there it is, and it goes through the y-axis at 0. And now we know that a horizontal line has an equation of y equals to the place where it goes through the y-axis at 0. So y is equal to 0. Now you can see the two asymptotes are drawn on the y-axis and x-axis for an hyperbola that didn't move up or down or left or right. Okay, got it? But a hyperbola also have two lines of symmetry. Now, can you remember what lines of symmetry are? They are straight lines that divide a graph into equal parts. And yes, a hyperbola has two lines of symmetry. Now, the one is y equals x. So if a hyperbola didn't move up or down or left or right, its first line of symmetry is y equals to x. So in other words, it's a straight line that's upward sloping, and it goes through the origin like this, and there it is. Now it simply means this is a straight line. The gradient is 1, so that basically means the coordinates will always be the same. So if the coordinate for y is 1, the x will also be a 1, and we will be there, okay? And 2 and 2 and 3 and 3, etc. Then the next line of symmetry is y equals minus x. So the gradient is negative, so it's a downward sloping line that goes through the origin like this. Okay, so there's the two lines of symmetry. We don't see them, but they are there. So they are the two lines that divide hyperbola into two equal parts. So let me quickly show you. Our a value is a positive 3, so we know we're going to draw it in quadrant 1. There it is. And there it is in quadrant 3. And as you can see, this half is the same as the other half on the other side, and the same here and here, as well as this part is the same as this part because of this line of symmetry. Now, what's going to happen now is, as soon as we move an hyperbola up and down and left and right, everything you see here shifts and moves. So let's look at the example. This is the same hyperbola as this one because it's got the same a value, right? But we basically took this hyperbola and moved it 5 places to the right and 3 places down. So look at everything here and look at what's going to happen. So we're going to move our entire system 5 units to the right. So 1, 2, 3, 4, and 5. Okay, and then we're gonna move it 3 units down. So 1, 2, 3. And there is our hyperbola, the same as the one that we drew in our previous lesson. Because now we easily know, if we want to know what the equations of the asymptotes are, we can see it, right? Okay, so our vertical asymptote will be x is equal to 5, and our horizontal asymptote will be y is equal to minus 3. The same as here, and we calculated it in the previous lesson. But now look at the lines of symmetry. They don't go through the origin anymore, okay? So that basically means our lines of symmetry get the same movements as our hyperbola. So basically what I'm telling you is that we can always ask you what are the equations of the lines of symmetry for this hyperbola. And what you have to do is you have to remember that before these movements, these lines of symmetry were y equals x and y equals minus x. This is the positive line of symmetry and this is the negative line of symmetry. So let's see how they change as we change our hyperbola. So we're going to start with the positive line of symmetry, just the normal one before there was any movements. Okay, so it's going to be y equals x. And now we're going to introduce the same movements as what happened to the hyperbola. So x is now x minus 5. So we cannot have an x here. We're going to have x minus 5 in its place. So how do we do substitution? Brackets first, and in the place of x, we're going to put x minus 5. So x minus 5, and then we also had a downward movement of minus 3. So we're going to put that on the outside. So minus 3. There we go. And once we do this calculation, we will see that y is equal to x minus 8. And there we go. And as you can see, it makes sense, right? Because 8 will be down here somewhere on our y-axis, which is our y-intercept. Now, how about the negative line of symmetry? Now, before these movements, we have to remember that the negative line of symmetry was y equals minus x. But then it moved 5 units to the right and 3 units down. So let's introduce those movements. Now, in the place of x, we're going to put x minus 5. So we're going to leave the minus at the front, and in the place of x, we're going to put the x minus 5, and there we go. And then we have to introduce the downward movement too, which is minus 3. We do this distributive law, minus x, and then it becomes a plus 5, minus 3, and you will see that our end result is y equals minus x plus 2. And there is our two new symmetry lines that suits this hyperbola. Now this is a very important lesson, and please remember the original two, and whatever happens to the hyperbola needs to happen to the lines of symmetry. See you again next time. Bye.